Hello guys, now this is sort of following on from a podcast that I took part in looking at communications in a steampunk world, and in that podcast I demonstrated these two things here, which is a Morse key and a Morse sounder. Now I'd like to do this little video just to talk to you a bit more about these two pieces and how they actually work. So we'll start with the Morse key, as that is by far the most simple device. So this here is a Morse key. It's basically just a push to make type switch. So as you push down on that, it makes a contact up here in the top of the bar. So if I just show you that to the camera, you can see that contact being made. So that is the Morse key. Now underneath this you can see how the contact actually follows all the way through, that it comes from the big brass terminals on the back here via a copper bar to the spring and then to the actual key itself. And then the other side is just straight wired onto the key. So that is the Morse key. The Morse sounder is altogether more complicated. Now this is really quite old, and it is made, I think this is actually bronze, it might be military spec brass, I'm not entirely sure, it doesn't quite look like normal brass. This came from an army salvage place, and I believe it is First World War era. It could even be older than that, I'm not entirely sure. This basically has two coils here which form electromagnets and pull this bar down. So as this bar is pulled down, you can see it pulls against a spring, and then there's various stops and other little contacts here. Now I believe these contacts are to allow this to relay on to other machinery, but I honestly can find very, very little information on how this thing is actually supposed to work. So if anyone out there does have any more information, that would be nice to know how this thing was supposed to work, whether these sort of little pins here were supposed to be contacts to connect other machinery, and also what the purpose of this switch is on the bottom, which appears to be in one position the thing works and in the other position it doesn't. I'm assuming that's not its original purpose. I'm assuming that was to turn on or off, as I say, whatever machinery this may or may not have been connected to relay the message on further up the line. So if I just turn this on, and this is not going to work. Why is this not going to work? One moment. Right, sorry about that. This thing is, as I have already said, quite old, and it can be quite temperamental. Some of the contacts are not the best. It does take a while to actually adjust this thing to the point where it is going to work. I don't really think it's supposed to be picked up and moved around while it's connected. But now you can see if I press this Morse key here, the bar drops. So if I just hold that up to the camera like that and press the key, so you can do a short press or a long press. Now one of the coils is a little bit loose, which is why you can see the coil moving, which it shouldn't really do. The bar is also slightly off centre, but I can't get it to, if I centre it the thing doesn't move, so I've kind of just got to live with that. But when I press the key, it appears something happens at that end. Now, to demonstrate this, I've got it just hooked up to this, which is an old model railway controller, and I've purely got it hooked up to that because it's the easiest, smallest, most portable variable voltage power supply I could find, because, as I've already said, this thing is very old. What I really don't want to do is fry the coils by running too high a voltage through it, so I've literally just turned this up to the point where it just about operates it. Now, this has just got a couple of meters of pseudo old cloth covered flex here to connect the two items together. In reality, these things would be miles apart, probably with the key having a little power supply for the key, which then would run through some relays to boost it up to quite a high voltage to transmit at, or it could even transmit wirelessly through either a valve type or a spark gap type transmitter. Then there would be some sort of receiver station. Now that could be via a wire if it was a telegraph type system, or a radio receiver if it was via radio waves, where this thing would be. And again, you'd have relays to step the voltage down and to actually operate this, because this runs at around about 6 volts from my experiments. It may have been designed to run higher voltage than that, but that's the lowest voltage I can put through it and actually get it to move, which is what I am limiting it to, basically because I don't want to damage it and I can't find any specification sheets for it. So that is these two little devices. At some point I do want to set these up properly, put together a couple of little relay stations. I've got some relays downstairs in the garage. At some point I want to set this up properly with relays so it will transmit as the original system would have. But this is essentially the most basic of telegraph systems. So this would require an operator at each end. Now really you need both these machines at both ends so you can send messages back and forth. This is just a one-way setup. So you'd have an operator sat with this who could interpret the Morse code, write it down in plain English. You'd have an operator with this that could turn a plain English message into Morse code and tap it out on this machine. That is basically how this system would have worked. As I said, this is a very basic telegraph system. Other systems did follow on from this using things like ticker tape machines, which automatically output something in plain English. There were, obviously, before you put it into Morse, you could put the message into some sort of code. So if you were transmitting during a war and you didn't want the enemy, especially if you're transmitting wirelessly, to be able to intercept your message, you could put your message into some sort of code before you then put it into Morse code. And again, it would just need the operator at the other end to be able to decode it. But this is a very basic little telegraph system, and I hope you've enjoyed this. Any questions, just ask. There's probably somebody out there who knows a lot more about these things than I do. What I've learned after acquiring these two things. If anybody else, just one final point. This little Morse sounder I got from a company called Johnson's of Leeds, which are an Army, Navy, Air Force salvage place. So this I know is military. The Morse key came from a junk shop in York. Now, I'm not entirely sure that this is genuinely old. I suspect it might be a film prop. And that's basically because the way comparing the two devices, all of the brass work or bronze work on this one is all machined brass, whereas this is just bent from brass bar stock. So I suspect this was made to look old, possibly for a film or TV production, but I'm not entirely sure. It could just be that it's the difference between a military version and a civilian version. I really don't know. The two things definitely were not originally part of the same system. But yeah, so that is my Morse coding system, and if anybody's interested, no, I don't actually know Morse code. So for all I know, when I've been doing this sort of thing, I could have been swearing at you. I honestly don't know. At some point, I do want to learn some Morse code and actually have a proper play with these things, get them set up with some relay stations, and actually do something proper with them. At the moment, normally they're not wired up. They do just sit as kind of display pieces with my steampunk computer. But anyway, I hope you've enjoyed this very brief look at a couple of bits of early telegraph equipment. If you like this content, please like the video, subscribe so you get to see my future videos, and thank you very much for watching.